Mu1 notes graphs of trig functions. First definition we have here is a periodic function, and what it basically means is it's a graph that continuously repeats itself. Let me give you an example. Let's say we had this graph right here, a little smiley face. If we were to take that graph and copy it over and over and over again, that would be called a periodic function, the function that made that graph. It's a function that repeats itself over and over and over and over and over again. Next we have period, the least positive value for alpha, for which f of x equals f of x plus alpha. That means the horizontal length of a graph before it repeats itself. If you look at the little example that I just gave you, it looks like the horizontal length of this smiley face is 1. Every time we go one more unit to the right, it repeats itself. So the period for that function would be a 1, because its horizontal length is 1 before it repeats itself. Part A, find each value by referring to the graphs of the trig functions. We have sine of negative 90 degrees. If we were to draw an angle in standard position, negative 90 means that we're supposed to go clockwise, starting here at 0. That puts us down on the negative y-axis. At that point, x is 0, y is negative 1, and r is 0. Sine of negative 90, sine is always y over r. Or in this case, we're saying y is negative 1 and r is 1. Negative 1 divided by 1 is 1. So this first question, sine of negative 90 degrees is negative 1. Number 2 is secant of negative 45 degrees. If we draw negative 45 degrees, that's clockwise from the standard position, which would be from the positive x-axis. So we're starting here at 0 and we're rotating clockwise 45 degrees. That would give us a 45, 45, 90 triangle. We can make x whatever we want. I'm going to choose 1. That makes y have to be negative 1. That makes r have to be the square root of 2. Secant is r over x. It's reciprocal of cosine. R is square root of 2, x is 1. Square root of 2 divided by 1 is the square root of 2. Number 3, we have cotangent of 840 degrees. You might find that 840 is not a comfortable angle to use, so you could find a coterminal angle. To find coterminal angles, you add or subtract complete revolutions. If I subtract 1 revolution, that's 360, which is not really enough. I'm going to subtract 2 revolutions. So I'm taking 840 minus 720, that's 2 revolutions. That's going to give me 120 degrees. If I draw 120 degrees from standard position, it's going to give me this angle here. That makes the reference angle 60 degrees, which gives me a 30, 60, 90 triangle. Opposite 30 I'm going to call 1. It's my smallest side. Since I went left, that's a negative 1. Opposite 90 is twice that, but the radius is always positive. Opposite 60 is whatever's opposite 30 times the square root of 3. Since we went up, it's positive, so it's positive square root of 3. So cotangent of 840 degrees, cotangent's always x over y. We're saying here that x is negative 1 and y is square root of 3. If you rationalize your fraction, you're going to get negative square roots of 3 over 3. A couple more definitions here. Domain for trig functions, all the angles that can be put into the function, all the numbers included from left to right. So the domain is referring to the angles that you're allowed to put into the function. The range for the trig functions, all the values that come out of the function, all the numbers included from the top and bottom. That's going vertically. So the range is the fractions that you get. So for example, sine of an angle equals y over r. Y over r represents the range for the function. Next thing we're going to do here is we're going to graph all 6 parent graphs of the trig functions. And the first one is y equals sine of theta. To do this, I'm going to draw a y and x axis just like we've done many times before. This is not the actual graph, this is just preparing us for this. I'm going to label the quadrantal angles 0, 90, 180, 270, 360 degrees. Then I'm going to mark what x, y, and r are at those locations. At 0 degrees, x is 1, y is 0, and r is 1. At 90 degrees, x is 0, y is 1, and r is 1. At 180, x is negative 1, y is 0, and r is 1. And at 270, x is 0, y is negative 1, and r is 1. Things that we've talked about before. That's a review for you. So we could say in each of these, for each of these quadrantal angles, sine of 0 degrees, that's y over r, that's 0 over 1, which is 0. Sine of 90 is 1 over 1, which is 1. Sine of 180, 0 over 1, which is 0. Sine of 270 degrees is negative 1 over 1, which is negative 1, and sine of 360 degrees is 0 degrees. So basically we have some ordered pairs here. We have 0, 0, 90 degrees 1, 180 degrees 0, and 270 degrees negative 1, 360 degrees 0. We're going to graph those points on the coordinate plane below. Here's how this graph works. Now it's already done for you here, but here's how it would work. You're going to label the x-axis from 0 to 360 degrees. And you can give different amounts of spaces when you do this. I gave 3 spaces. You could pick 1 space for 90, 2, 3, 4. It doesn't matter as long as you can fit 1 period on here. A period, once again, is the horizontal length before it repeats itself. If I take the ordered pairs that I had above up here in my notes, sine of 0 degrees is 0. So at 0 I put a dot on 0. Sine of 90 degrees is 1. So I put a dot on 1. Sine of 180 is 0. I put a dot on 0. Sine of 270 is negative 1. So I put a dot there. And sine of 360 degrees is 0. So I put a dot there. I then connect those dots with smooth curves. The beginning from 0 to 180 degrees, it's concave down. It's like part of a parabola. And from 180 to 360, it's concave up. That represents 1 period of sine. That's the unique shape that's repeated for itself over and over and over again. Let me show you more of this. If we were to take that same shape and copy and paste it over here, we would have, we would have this. Remember, this is a periodic function. It repeats itself forever, from left to right, always repeating itself. When you choose to label your y-axis, you want to do it intelligently. But in the case where you're going from negative 1 to 1, it doesn't matter. You could go up 1 dot and call it 1, or 2, or 3. I just happened to go up 3 dots and call that 1. I went down 3 and called that negative 1. This is what the graph of sine looks like. You should memorize it, its basic shape. These points, once again, that we get here, 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 and here, those points come from what we did up here. That's all from this right here, which came from, in essence, the unit circle. So some questions at the bottom that we need to answer. First question is, what is the domain of this? And I'm telling you it's everything. Any number you can think of, you can put in for an angle. It goes from negative infinity to infinity. Remember, these parentheses means it does not include the number, because infinity is not a number. Here's how we know the domain's everything. I can go from left to right and trace over this, never lifting up my pencil. It goes forever left and right. It never stops going left and right, just continues. The range is how far up and down it goes. As far as up and down, the graph never goes above 1, and it never goes below negative 1. The graph is every place between there, but it never goes above or below it. That's why we say the domain goes from negative 1 to 1. It includes negative 1 and 1 because the graph goes as high as 1. That's why it's a bracket, and it goes as low as negative 1. So it should be memorized or be able to derive that the domain for sine is negative infinity to infinity, and the domain or the range for sine is negative 1 to 1. This is the parent graph for sine. Number 2, we're supposed to graph y equals cosine of theta. And you know, this theta here, it could be anything. It could be a theta, could be an x, doesn't matter. This is the same information I had from sine. I labeled my x and y r values at my quadrantal angles. Cosine, which is x over r, is going to give me cosine of 0 degrees is 1, cosine of 90 is 0, cosine of 180 is negative 1, 270 is 0, and 360 is 1. That's going to give me similar points to sine, but it's a little bit different. Let's see what this graph looks like. Here's what the graph of cosine looks like. Since we said cosine of 0 is 1, at 0 degrees we put a dot on 1. At cosine of 90 degrees was 0, so at 90 degrees we put a 0. 180 was negative 1. 270 was 0. Be a dot there. And that dot is humongous. And then at 360 degrees, it was at 1. You connect that with a smooth curve once again. This is the same curve as sine, it's just translated a little bit to the left or to the right, depending on your perspective. When you connect these points, make sure that you have distinctly concave up in this location, and in here it's concave down. This graph continues forever to the left and to the right. If we were to make more than one period, we would see that this is continuing as you see it here. Just keeps repeating. It's going down to negative 1 and then up to 1, and down to negative 1 and up to 1. It's hitting the x-axis every 180 degrees. It's hitting 1 every 360 degrees. It's hitting negative 1 every 360 degrees. So that is the parent graph for cosine. Once again, when I labeled the x-axis, I just chose to go 3 spaces every 90 degrees is 3 spaces. When I went vertical, I went every vertical space was a third, which means every 3 spaces is 1. You can choose different spacing as long as you're consistent when you choose your spacing. As far as the domain and range, the domain is also all real numbers, just like it was for sine. The domain is what you can put in for the angle. If you look at our graph, from left to right, that's the domain. The graph is continuous from left to right. We can put in anything we want. That's why it's negative infinity to infinity are all real numbers. The range, our graph never goes below negative 1, and it goes every number between up to 1. So the range just goes from negative 1 to 1. When you do domain and range, always start from the smallest and go to the biggest. So for the smallest for the domain is to the left. Since the graph is all the way to the left, it's negative infinity. Since it continues to go to the right and never stops, it goes to infinity. For the range, the lowest numbers are at the bottom. There's no graph, there's no graph, there's no graph, there's no graph. Once you get to negative 1, the graph starts. That's where the range starts. And it continues until you get to positive 1. That's why the range is negative 1 to 1. That's the parent graph for cosine. When we get to tangent, things are a little bit different than they were for sine and cosine. And hopefully once you see this whole thing, you'll understand why. If we just do these quadrantal angles for tangent, we're going to end up with tangent of 0 is 0, tangent of 90 is undefined, tangent of 180 is 0, tangent of 360 is undefined. It doesn't tell us what the graph looks like. It doesn't give us enough information. So for tangent, we need to add in some angles between our quadrantal angles. So I went halfway between, and I went with 45 degrees and 135. It doesn't matter what you choose when you're trying to figure out what this looks like. And you could just flat out memorize it and you don't have to choose anything, but I think deriving it is better. So if I went with 0 degrees, tangent is y over x. 0 divided by 1 is 0. That's why it's 0. At 45 degrees, if I make this triangle here, the two legs are both 1. Hypotenuse is square root of 2. So tangent of 45, which is y over x, is 1 over 1, which is 1. Tangent of 90 degrees is 0. Is undefined because 1 divided by 0 is undefined. Tangent of 135, that would be give me a 45 degree reference angle, makes this angle 135. X is negative 1, y is 1, and r is square root of 2, which makes tangent of 135 negative 1, because it's 1 divided by negative 1. And then tangent of 180, which is over here, is going to be y over x. 0 divided by negative 1 is 0. Let me show you what this graph looks like now. So if I put those points on here, here's how this looks. Tangent of 0 degrees was 0. Tangent of 45 degrees was 1. Tangent of 90 was undefined. Undefined means there's a vertical asymptote. Tangent of 135 was negative 1. Tangent of 180 degrees was 0. If I were to continue to do more points around the circle, I would find that the points that I just had repeat itself. So for example, if I were to do tangent of 225 degrees, I would get a point of 1. And then if I did tangent of 270 degrees, I would get undefined once again. Tangent's period is smaller than sine and cosine. It's actually 180 degrees. Its horizontal length before it repeats itself is 180. So if I were to show you here, let me try to highlight this. What you see in this highlighted area, that is the period for tangent. That's the part that repeats itself over and over and over and over again. From negative 90 to 270, we got these vertical asymptotes, and then we have this curve. It's very similar to x cubed. That same thing repeats itself over here. From negative 90 to 90, we got these vertical asymptotes, and then we have this curve. This basic shape will repeat itself forever, from left to right, continuously. It's a periodic function. Its period is 180 degrees. Let's answer these questions at the bottom. Let's do range first for this one, because it's a little bit easier. Range is how far up and down the graph goes. What numbers are included in it? Well, as we can see, this curve is going down forever. So starting at the bottom, since it's down forever, that's negative infinity, and it continues, and it includes every number between negative infinity until it goes up forever to infinity. So the range is all real numbers or negative infinity to infinity. Let's look at the domain. If you look at this, like in this region, the domain includes all the numbers between negative 90 and 90. It's going from left to right. Doesn't include negative 90 or 90. So it jumps over the vertical asymptote each time. So essentially, the domain is everything but the vertical asymptotes. So we have to try to include that in our answer. So here's what we do. We say the domain is everything, all real numbers. That's a capital R with an extra vertical segment. That means all real numbers. Except the vertical asymptotes. We can't just say except them, we have to say where they are. Pick one of your vertical asymptotes. Doesn't matter which one you pick. I'm going to choose the first positive one, which is 90 degrees. You could also pick negative 90, you could pick 270, it doesn't matter. Then you add to that, how far apart are these vertical asymptotes from each other? This one's at negative 90, this one's at 270. They're 180 degrees apart. So we're going to say all real numbers except for 90 degrees plus 180 degrees k, where k is any integer. So if k is a 0, it's going to be 90 degrees plus 0, which is 90. If k is a 1, that's 90 plus 180, which is 270. If k is a 2, that's 90 plus 360, which is 450. If k is a negative 1, that's 90 plus negative 180, which is negative 90. That covers all the vertical asymptotes. This is the domain and range for the parent graph for tangent. You need to be able to memorize or derive that whenever you're asked to do so. Continuing with these parent graphs, we're supposed to graph cosecant of theta, what's the reciprocal of sine. If you label this like we did for the first three, the quadrantal angles, we don't need 45s like we did for tangent, just the quadrantal angles. Cosecant, which is reciprocal of sine, so it's r over y. 0 degrees is going to be undefined, 90 degrees is 1, 180 is undefined, negative 1 for 270 degrees, and undefined for 360. So what will that look like? Let me show you. If you graph those points, here's what you would get. Cosecant of 0 degrees is undefined, so we draw a vertical asymptote at 0. Cosecant of 90 degrees is 1, so we put a dot at 1. Cosecant of 180 degrees is undefined, vertical asymptote. Cosecant of 270 degrees is negative 1, so we put a dot there. Cosecant of 360 is undefined, it's a vertical asymptote. You have to trust me on this, that those points that are there, which you obviously know, that ends up being the vertex of a parabola. So we got a parabola that opens up where it's 1, and we have a parabola that opens down where it's -1. This is one complete period for cosecant. This repeats itself over and over and over and over again. Once again, this graph is repeated forever, left and right. It's because it's periodic. That's what a periodic function means. So let's answer these questions down here at the bottom. So what is the domain? Well, moving from left to right, starting forever on the left, you can see this graph is going forever to left and right, but it doesn't include everything. It's everything except for these vertical asymptotes. So once again, we're going to say the domain is everything except. Pick any of the vertical asymptotes. I'm going to pick this one here at 0. Sorry about that. Pick any one you want. I'm going to pick 0 degrees. And then add to that the distance that each of these vertical asymptotes are from each other. So 0, which I'm not going to write down because 0 plus anything is at anything, plus 180 degrees k, that's how far apart they are. They each go 180 degrees, where k is any integer. So if I pick any integer and put it in for k, that would land on one of the vertical asymptotes. So the domain's everything but the vertical asymptotes. Range, if I look at my graph going up and down, it starts down forever and it goes up, hits -1 and comes back down. So the first part of my range goes from -infinity to -1. It includes -1. Then, all in this region, there's no part of the graph. Nothing blue in here. Doesn't start up again until it gets to 1. When it gets to 1, it goes up forever. So I'm going to unite this, u, with 1 to infinity. So that is the range for cosecant. This is the parent graph. Parent graph information needs either to be memorized or be able to derive it when asked to do so. And you will be asked. You can believe that. Next graph is secant. Just going to fast forward here a little bit. Try to make this as short as possible. Same thing we did for the other ones. You're going to get secant of 0 is 1, secant of 180 is -1, secant of 360 degrees is 1, secant of 90 and 270 is undefined. This is a similar graph to cosecant. It's just translated a bit. So 0 degrees is a 1. Put a dot at 1. 90 degrees is undefined. It's a vertical asymptote. 180 degrees is -1. We put a dot. 270 degrees is undefined. And 360 degrees is a 1. Once again, these dots represent the minimums or maximums of parabolas. So we got a parabola, parabola, parabola. This graph repeats itself forever and ever from left to right. And once again, the period for this is 360 degrees. The horizontal length before it repeats itself is 360. If we look here, this basic shape is what's being repeated over and over and over. Vertical asymptote, parabola, concave up, vertical asymptote, parabola, concave down, and then a vertical asymptote again. So the domain for this, it's all real numbers except for where the vertical asymptotes are. So I picked the first vertical asymptote was at 90 degrees, and I added to that how far apart they are forever. They're 180 degrees apart. So it's all real numbers except for 90 degrees plus 180 degrees k, where k is any integer. The range goes from -infinity to -1, and then it goes again from 1 to infinity. Cotangent is very similar to tangent. If you were to put these points on here and also do the same thing for the 45 and the 135 degrees, you would get these ordered pairs. 0 undefined, which is a vertical asymptote, it's not an ordered pair. 45 degrees 1, 90 0, 135 -1, and 180 undefined. That would give you this graph here. Vertical asymptote, 45 1, 90 0, 135 -1, vertical asymptote. Tangent shape was like this, similar to y equals x cubed. Cotangent is that reflected over the x-axis. Yeah, over the x-axis. So it's shaped in the opposite direction, as you can see here. Tangent and cotangent, their period length is 180 degrees. That's their horizontal length before they repeat themselves. If you look at this portion here from 0 to 180, this is the entire graph. It repeats itself over here, and it would again over here, and it would again over here. It continually repeats itself forever, going from left to right. That's a periodic function. These are all periodic functions. So questions down here to answer once again. What's the domain and what's the range? Let's do that. The domain is everything except for the vertical asymptotes. The first one happens at 0, so it's all real numbers except for 0 plus 180k, because the vertical asymptotes are all 180 apart. 0 plus 180k is just 180k. So I'm just going to write it as all reals except for 180k, where k is an integer. Range is how far up or down the graph go. They go up and down forever, and every number is included between them. So it's negative infinity to infinity, which is also all real numbers. Find the values of theta for which each equation is true. This is example B. Number 1 says that sine of theta equals -1. Well, sine is y over r. So that means that y is -1 and r is 1. If you change -1 to a fraction, it could be -1 over 1, or it could be 1 over -1. The reason it can't be 1 over -1 in this case, that would make r -1, which it can't be. So that means -1 goes with r and 1 goes with r. Or -1 goes with y and 1 goes with r. Sorry, I misspoke. If you draw that, the only place that could happen in the coordinate plane where y is -1 and r is +1 is at 270 degrees, or you could say at -90 degrees, or you could say at 270 plus 360 degrees. It's this location. That location happens lots of times, going around and round and round. So to include all answers, we would say that theta is 270 degrees plus, now this plus is important, it's plus the period of the trig function. Sine's period is 360. So every 360 degrees is going to repeat itself. So we say 270 plus 360k, where k is any integer. But any integer you want in for k, and that will land on that same spot. Number 2, secant of theta is 1. 1 as a fraction could be 1 over 1, or it could be -1 over 1. Secant is r over x. Therefore, it couldn't be -1 over -1, because that would mean that r would have to be -1, which it always has to be positive. Therefore, r is 1 and x is 1. When does that happen? Well, that happens on the positive x-axis. What degree measure is that? Well, it's 0 degrees. Since the period length for secant is 360, it's going to be 0 degrees plus 360 degrees k, where k is any integer. Adding 0 to anything doesn't change its value, so we could just say that theta is 360 degrees k, where k is any integer. Once again, the direction said find all values of theta, not just one value, all values. Number 3, we get tangent of theta is square root of 3 over 2. Tangent is y over x. That means that y could be square root of 3 and x could be 3, or it could mean that y could be -3 and x could be -3. So they could be negatives or positives, because if you divide two negatives, you get a positive. So where does that happen? Those are special right triangles. If y is 3 and x is, if y is square root of 3 and x is 3, that would give you a 30, 60, 90 triangle. Opposite 30 is something, square root of 3. Opposite 60 is that number times the square root of 3. Square root of 3 times the square root of 3 is 3. It's a 30, 60, 90. It could also happen here in quadrant 3, where opposite 30 is negative square root of 3, and opposite 60 is negative 3. So the answer to this, what could theta be? Could be 30 degrees plus 180k, where k is any integer. The reason that we're choosing 180 here instead of 360, the period length for tangent is 180. That's how often it repeats itself. Now, if you look at this picture, we have two answers. We have this one, and we have this one over here. The reason we don't have to include this answer here, even though I just drew it, because that answer is included in our first answer. 30 degrees and 210, which is where this other one is, are 180 degrees apart. So this first answer that I gave, 30 degrees plus 180k, where k is any integer, it included both answers. So some may say that this was pointless to do, but I just wanted to make sure that both solutions were included in that. Part C, state the domain and range for each function. Well, sine of theta, its domain is all real numbers, which can be stated as all real numbers, capital R, or negative infinity to infinity. Its range, it goes from negative 1 to 1. It includes every number in between. Secant, its domain. Well, it's all real numbers except for the vertical asymptotes. And where do they hit? They hit starting at 90 degrees, and they're equally spaced every 180 degrees after that. So it's 90 plus 180k, where k is any integer. The range for secant, it includes everything except for the numbers between negative 1 and 1. So it goes from negative infinity to negative 1, and then it picks up again at 1 and goes to infinity. Tangent, its domain is everything except for the vertical asymptotes that happen starting at first 90 degrees, and then they're equally spaced every 180 degrees after that. So we say all real numbers except for 90 plus 180k, where k is any integer. The range, tangent goes up and down forever, so it's negative infinity to infinity. The reason I know those answers is because I know the parent graphs. The answers to these questions for part C are on the front of your notes, the domain and range for each of those. If that requires you to memorize them, then do so. If it requires you to derive them each time, then do that as well. Example D, graph each function on the given interval. Supposed to graph y equals sine of x from 0 degrees to 360 degrees. Well, if you go back to the front of your notes, parent graph for sine, or if you just derive it, sine of 0 degrees is 0. So I put a dot at 0. And then sine of 90 degrees is 1. So I would put a dot at 1. So I'd have a dot here, I'd have a dot here. Sine of 180 degrees is 0, so I put a dot here. Sine of 270 is negative 1, I put a dot here. Sine of 360 degrees is 0, I put a dot here. I connect those with a smooth curve, concave down, then concave up, and that is the graph. It's asking for the parent graph with a specific portion from 0 to 360. Number 2 is supposed to graph secant of x from negative 90 degrees to 270. Here's what that would look like. Secant of negative 90 degrees is a vertical asymptote, which is denoted here. Secant of 0 degrees is 1, so I put a dot there. Secant of 90, vertical asymptote, is undefined. Secant of 180 is negative 1, and then secant of 270 is a vertical asymptote. I memorized my parent graphs, so these dots represent parabolas, like so. And there's my graph. Supposed to graph tangent of x from negative 540 to negative 90 degrees. Here's how that would look. Tangent of negative 540 degrees is 0. Tangent of negative 450, undefined. Tangent of negative 360 is 0. Tangent of 270 is undefined. It's negative 270. Tangent of negative 180 is 0. Tangent of negative 90 is undefined. Now I know what the graph looks like. It's supposed to be curved like so. So I draw the curves appropriately through those points. Finished. I just want to make sure this is clear. The period of 360 degrees, the functions that have that are sine, cosine, secant, and cosecant. The ones that have a period of 180 degrees are tangent and cotangent. Period, once again, is the horizontal length before it repeats itself. Sine, cosine, secant, and cosecant have 360 degrees of unique shape. Tangent and cotangent have 180 degrees of unique shape.